Speaking the language of the OSI model. When I first got into certifications, I stepped into the world of Microsoft. This is 20-some years ago when Microsoft played a little more heavily in the networking space than they do nowadays. And I still remember learning the OSI model because I had to memorize it for the certification exam. So what I learned of the OSI model was, please do not throw sausage pizza away, because the only thing that Microsoft really cared about was, do you know the layers and do you know what order they go in? Because from a Microsoft server's perspective, it doesn't really do much more than that. It sits up here at the application layer. So I get into the Cisco world and I see the OSI model again. I'm like, sweet, one less thing that I have to learn, because please do not throw sausage pizza away. I've got it, right? I know the layers of the OSI model because that's all that was relevant. And I didn't understand how valuable it is to speak the OSI model. See, as I'm recording this revision of CCNA, this is like the fourth or fifth time I've actually re-recorded CCNA as it's been upgraded over the years. I took a totally different approach. I said, you know what, before I even talk about network models, I want to talk about the concept of networking, because I don't want the model to show up and everybody's like, what's that? It's not relevant to me until I see the concepts. And I found it really hard to actually talk about the concepts that I have in the series up until now without referencing the OSI model. I'm biting my tongue. I'm like, oh, that's a layer. I can't say that because we haven't talked about it. In the world of Cisco networking, you start speaking OSI. To understand what that even means, come with me on a little journey back in time to a much slower era. When TCP/IP was being created, 1960s, 70s timeframe, they actually created a protocol right alongside it called OSI. Now, notice I said protocol, not model, right? And OSI was created as an alternate standard to TCP/IP. And as fate would have it, TCP/IP ended up winning, right? It's similar to, some of you are old enough to remember the video cassette tape players, VHS players, right? And we call them VHS players because VHS was the actual standard that won, but many of you will remember there was actually another one out there called Beta. And Beta was the better standard, but I don't know, mafia involvement or whatever the case is, VHS ended up winning, at least in the consumer space. In production studios, they used Beta for years to come because it was actually a higher quality picture. But anyway, VHS ended up winning, right? And it's the same kind of thing. OSI was actually the better protocol, but TCP/IP was simpler. We lived in a simpler time back then, and that ended up winning. And ironically, TCP/IP version 6 actually looks very similar to the original OSI protocol. But nonetheless, as fate would have it, TCP/IP ended up winning, but the OSI design and architecture was so good that they continued to use the model created for OSI, meaning the model created to describe network communication to architect networks to this day. As a matter of fact, this model has become so integral to network design and communication, you just start learning to speak it as a network engineer. I'll be in a data center and troubleshooting with another individual, and I'll say something like, we're not getting out. I think this is a layer 2 issue. Why don't you give AT&T a call and see what we can do there? Or I'll be trying to troubleshoot communication and be like, I think there's must be like a layer 3 or a layer 4 filter that is blocking this communication. I can ping it, but so you just start speaking it in terms of your normal communication, which immediately sets everybody's mind on exactly what area to focus, right? So big picture, this is a standard architecture that defines network communication from top to bottom. And I'm actually going to unpack that statement on the next slide, so I'll hang on for just a second. It helps break down network communication. You ever been, well, if you haven't, you will be, at a relative's house, because as soon as they find out you're involved in computers, they all turn on you and they're like, hey, come on over for some unrelated event. And when you get there, they're like, hey, actually, while you're here, that's where, because my computer is, it's got, some, can you just take a look at it? You're like, oh, I sucked in. So when you're troubleshooting computers, the first thing you say is, what's wrong? And if they just turn back at you and say, well, my computer doesn't work, what does that tell you? The first thing you start doing, you're like, well, does it turn on? What do you mean? Does it not boot Windows? Do you boot up and you get random pop-ups? What you're doing is you think of a computer as you're thinking of all the things that you could go wrong. And you're actually doing it in a layered approach. You may not say it that way, but I mean, just think of what I just said. Well, is it on? So you're thinking of the layer, like, okay, maybe it's a power supply. Maybe it's not plugged into the wall. Maybe the wall socket is bad. Maybe there's a connection problem between the monitor and the desktop unit or something. Like, again, we're thinking, what are we thinking? Physically. Right? Well, something's wrong there. Okay. So it turns on, but it looks like you boot the operating system and you get a blinking cursor in the upper left corner, and you start thinking, okay, hard drive failure or video. You see what I mean? Like, we think in layers without even doing it. And so imagine trying to talk about network communication without a layered approach. I mean, hey, the network's broken. Okay, like how? Well, so you start going, well, is it, is your cable physical? So you see what I mean? And I'll describe all these in just a second. So this is also a standard to create standard. I'm biting my tongue. I don't know if you can tell as I'm talking to you. I'm kind of like, I'm going to bite my tongue because there's so much we could talk about as we do this. So it is a standard to create standards, meaning people can design equipment that just work at one of these layers. For example, we talked about switches earlier in this series. The switch actually works at the data link layer, meaning it handles data link layer stuff and everything below. Matter of fact, we've talked at this point in the series about MAC addresses, right? MAC addresses are a data link function. So the switch works at that layer, it learns MAC addresses and handles everything else below. It doesn't handle, as long as we're talking about a normal layer 2 switch, look, there I did it. I speak OSI. It's a normal layer 2 switch. That's the data link layer. But they have switches that work at layer 3. They call them layer 3 switches. Do you see what I mean? Speaking OSI, this is all coming to me as I'm talking to you right now. Layer 3 switching, speaking OSI, everything references and ties into these things. I think that's a good, solid introduction to the OSI model. This is what it is. This is why it's here. In the next nugget, I'm going to go through and unpack it in a hugely practical example so you can understand what the layers do and how devices communicate. For now, I hope this has been informative for you, and I'd like to thank you for viewing.